Hey everyone, and welcome back to another video. Today we are going to be diving deep into a very interesting project I have been working on in the world of ethical hacking and hardware security. We are going to be explaining exactly what the Brutal tool is on Kali Linux, how to set it up from scratch, and most importantly, how we can use it in a strictly ethical way to test the security of physical systems. For those of you who might be new to this specific niche of cybersecurity, Brutal is a specialized toolkit designed to quickly create various payloads, manage advanced PowerShell attacks, simulate virus behavior, and even launch listeners for a human interface device, or HID attack. It effectively streamlines the entire workflow of creating malicious scripts for hardware penetration testing, so you don't have to write them by hand every single time. Now, before we jump into the actual installation and code, let's talk a little bit about the hardware we are using today. You have probably heard of the USB Rubber Ducky. It is essentially the industry standard for HID attacks and is a fantastic tool. However, for this project and for my own personal security testing, I have chosen to use a Teensy device instead. You might be wondering, why am I choosing Teensy over the more famous Rubber Ducky? The answer is actually quite simple. The price is very cheap for me. It makes it a much more accessible option for students, researchers, and hobbyists who want to learn without spending a lot of money. But don't let the price tag fool you. Despite the lower cost, the Teensy is extremely useful. It is perfect for executing scripts on a target machine without the need for any human-to-keyboard interaction. This is the core concept of the HID attack. When you insert the device into a USB port, the computer does not see a storage drive or a virus. It detects it as a standard keyboard. Because computers inherently trust keyboards and human input, this allows us to bypass many traditional security checks like auto-run restrictions. Using the microprocessor and onboard flash memory storage, you can send a very fast set of keystrokes to the target's machine. We're talking about typing speeds that no human could ever achieve. This capability allows you to completely compromise a machine in a matter of seconds. I've used this extensively in my security testing to run reconnaissance or enumeration scripts, execute reverse shells to gain remote access, exploit local DLL hijacking or privilege escalation vulnerabilities, and even get all saved passwords for auditing purposes. Now, to make this easier for everyone, I have developed this new tool. The name is Brutal. Getting started with Brutal requires a little bit of setup, so let's move over to our Linux environment and walk through the installation process step by step to ensure you have everything configured correctly. The very first thing you need to do before even touching the terminal is to handle the dependencies. You need to copy and paste the PaensyLib folder inside your Arduino libraries directory. This is a critical step because PaensyLib acts as the bridge between your Arduino hardware and the payloads we are going to generate. Without this library in the correct folder, your Arduino IDE won't be able to compile the sketches that Brutal creates. So double check that this folder is placed correctly in your documents or installation path. Once that library is in place, we're ready to open up our terminal and pull down the tool. We're going to use git clone command for this. You'll want to type git clone followed by the URL https://github.com/screetstack/brutal.git. Make sure you type that correctly. When you hit enter, your system will reach out to GitHub and download all the necessary source code, the payload templates, and the configuration files directly to your local machine. Depending on your internet speed, this should only take a few moments. After the cloning process is finished and you have the confirmation message, we need to move into the directory we just created. Type cd brutal to change your current working directory. It's always a good habit to list the files here using the ls command just to make sure everything downloaded correctly. You should see the script file and a few folders. Now, by default, the main script might not have permission to run as a program. We need to change that. We'll use the chmod command by typing chmod +x brutal.sh. The +x flag is what tells the Linux system that this file is executable. If you list the files again after doing this, you'll likely see the file name turn green, indicating it's ready to run. Finally, to launch the toolkit, we need to run it with elevated privileges. This is because Brutal may need to interact with network interfaces or hardware drivers. So type sudo./brutal.sh. You could also switch to the root user entirely by typing sudo/su first and then running the script, but using sudo directly is usually safer. Once you hit enter and type your password, the Brutal splash screen will load up and we're ready to go. Now that we have the tool up and running, let's look at what we can actually do with it. The interface is designed to be text-based but very easy to navigate. You'll see a list of options corresponding to different attack vectors. For example, you can select options to generate payload specifically for grabbing system information, or payload designed to open a back door on the target system. When you select an attack, let's say a PowerShell attack, Brutal will ask you for the necessary configurations. It might ask you for your IP address if you're setting up a reverse shell, or the port number you want to listen on. Once you input these details, the tool automatically generates the Arduino sketch code for you. You don't need to manually write the complex C++ code or the PowerShell scripts. Brutal handles the syntax and formatting automatically. After the code is generated, your next step is to copy that code into your Arduino IDE. This is where the Teensy interaction comes in. You'll plug your Teensy device into your computer, select the correct board model in the IDE, and hit the Upload button. The code will compile, linking with that PaensyLib library we installed earlier, and flash onto the device's memory. Once the upload is complete, your Teensy is armed. In a real-world assessment, you would then take this device and plug it into the authorized target machine. As soon as it makes a connection, it will start typing out the payload we just created. It creates the illusion of a user typing incredibly fast, opening the command prompt or PowerShell, and injecting the code to execute the task, whether that's launching a virus attack simulation or setting up a listener. Speaking of listeners, Brutal also has a module to help you manage incoming connections. If you deployed a reverse shell payload, you need a way to catch that connection when the target computer calls back to you. Brutal can help automate the setup of a netcat listener or similar handler so that you're ready to receive the session immediately after the payload executes. It's incredibly important to remember that tools like Brutal are powerful and must be used responsibly. I chose the Teensy and developed this tool to help security professionals demonstrate the risk of physical access. It shows why organizations need to disable USB ports and train employees not to plug in unknown devices. You should only ever use this on hardware you own or have explicit written permission to test. Unauthorized access is illegal and unethical. Thank you so much for watching this tutorial. I hope this gives you a clear understanding of how the Brutal Toolkit works and how you can use affordable hardware like the Teensy to perform advanced security auditing. If you found this video helpful, please hit that like button. It really helps the channel, and consider subscribing for more content on ethical hacking, penetration testing, and cybersecurity tools. If you have any questions about the installation or the payloads, drop a comment down below. Stay safe, stay ethical, and I will see you in the next video.